Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistants, and today we are looking at the molecular orbital theory. We're asked to predict the certain properties of the anion of a difluoride. So let's take a look. We're asked to predict the electron configuration of this, and it can be somewhat intense. What we're going to do is list everything out from the beginning, noting both bonding and anti-bonding. So we've got our sigma 1s for bonding. There's two of those. Anti-bonding. Bonding. Anti-bonding. And then once you get past the S's, you have to take into account when lining up, basically what you're doing is you're taking all your electrons and accounting for all of them. And it's going to go to the bonding and then the anti-bonding and so on, so on, and so forth until you used up all the electrons involved. And thus far, they've all been sigma bonds, but here fairly soon, we're going to deal with some pi bonds. So we're going to go sigma 2px, the x dimension. And then now we're finally getting into pi bonds, 2py. And then we're getting into more pi bonds, 2pz. This is going to be some anti-bonding as well, so 2py star. Another pi bond. And then finally, leaving off with one last sigma bond in the anti-bonding position. Okay. In order to calculate the bond order, all we have to do is take the total number of bonding versus anti-bonding and take the difference of the two and then divide by 2. So your bond order is equal to, in this case, let's see, we've got, this is bonding, so there's 2, 4, 6, 8, 10, versus anti-bonding, which will be 2, 4, 6, 8, 9. Notice that there's only a 1 right there, so that's a total of 9 instead of 10. So we'll have 10 minus 9 over 2, which gives us a bond order of 1/2. Next, we're going to want to determine the magnetic properties. Because there is one unpaired electron, we know that this is paramagnetic. See how easy that is? If we had 2 electrons and they were paired up on that last one, it would have been diamagnetic. So if we come back up here, this right here indicates that it's unpaired. If it had been a 2 like over here or any of the other ones, then it would be diamagnetic. But because it's only 1, it's paramagnetic. So the last thing we want to look at is the bond length relative to an unionized version. So for this, we have to kind of think about it. For a difluoride, non-ionized difluoride, then you would have 1 less electron compared to the ionized version. So the ionized version has an extra electron. That extra electron is going to pull everything together a little bit more. And the result is going to be stronger short bonds. So we've got stronger shorter bonds. That's not to say that they are immensely stronger or very much shorter. They're just slightly stronger and slightly shorter than an unionized version of difluoride. Okay?